Welcome, Integrated Three Peeps. This is Mr. Cortez. I'll be off camera for this one. Hope you don't mind. This is Integrated Three. Welcome back. We are interviewing linear functions. Yeah, we're going to interview linear functions and talk all about how they dealt with the pandemic. A quick recap on linear functions. They take on this form here sometimes y equals mx plus b, or sometimes these get flipped around. You may see me rewrite linear equations like this because this says what your starting amount is. And there's a lot to review here. Like this might be considered your starting amount, or in graphing terms, your y-intercept. You have m, which is your slope, which is also known as your rate of change, which is also known as rise over run. I hope that we'll see these graphed out here today. And if anything else comes up, I'll do my best to remind you of what these terms all mean. You saw linear functions most likely in middle school and definitely in integrated one. And we'll just hop into it. Hopefully, this all rings a bell and you're able to do super well on this. And I'm confident you can. What's happening here? In an effort to attract employees, a fast food chain offers a $50 signing bonus along with a starting wage of $8 per hour. Not too bad. I think that should go up though in 2022. Let X represent the number of hours worked and F of X be the amount of money earned. So we're looking at, just adding on 1 hour every time as we move forward. How much money are we going to get? So we get this signing bonus. So even if we don't work at all, haha, we came up $50, Subway. And then after that, we keep getting 1 more hour of work. So we keep on adding $8 to that. And hopefully you see a pattern here. For every hour, we keep gaining $8. This can keep going and going. So it goes to 64, just like Nintendo. 64 and 8 gets you 72. And then after 4 hours, we can make $80. And we'll use the table to sketch the graph. Simple enough. We can make a pretty basic XY plane. Let's see. I'll have my number of hours go. Let's see. Let's go in increments of, for every 2 blocks, I'm going to have it be equal to 1 hour. Makes it a little bit more interesting, covers a bit more ground. And how can I have this go? What would you do? How would you size this up? What would you do to size this up in a decent manner? If it was me, maybe I would say that we start at, well, let's do units of 10. If you did something different, let me know. I'm so curious how you would size this up. And then for every hour, we gain 8, which gets us closer to the next increment of 10, but not quite. So use your best judgment on that. We can keep this going. 64 is a little bit below the middle, but pretty close to the middle, in between 70 and 60. And after you have a few of these, hopefully you can trust your judgment after a bit and just say, well, I could just keep dotting out these lines. And it's not a bad idea if you need to do it. But after a bit, it's going to be gone in this direction. Does that make sense? Did everything seem okay to you? You can then describe the pattern displaying in the table and the graph. You could say, and I love the wording of this in integrated. I know that they're big on it. Starting at 50, we adding 8. Not just 4 times that we do this. We'll just say it's I think that's a pretty decent way to describe this pattern. We have another way that we describe it. Okay, next example. I skipped a few elements of the previous one, but we'll definitely hit them here. I hope that's okay with you. John's car broke down. He has to get it fixed. It costs him $450 for just the parts, and the mechanic charges an additional $55 per hour. as integrated three students, you might be driving soon. You might be taking on these costs. So, I mean, over the summer, I paid a lot more than 450 for parts, but hopefully you don't have to pay too much in parts. And this, I don't know the going rate for the mechanic charge per hour, but this is pretty decent. So let's say that we just buy the parts and we have, I don't know, maybe we have a sibling that's really good with parts. We can just take the parts for 450 and have no hours worked, and that's fine. But if it takes a little bit more time, how do you think that's going to change from hour to hour? Well, you have to keep on paying $55 for every hour that it increases. So we're now popping up to 505. We're going to keep this going to 560. It would then keep going to 615, keeps going. I mean, hopefully it doesn't exceed 4 hours and it just kind of sits there and waits for you to pick it up. But who knows? And this pattern would just keep on going. So this is not too bad. And so you might think, all right, I just need to keep on adding 55 because that's what I did up here and here. And you'd think that, and that's pretty funny because what changed from here to here? And how does that compare to what you did before? Before you were adding one, and now you're jumping up quite a bit. So you have a few ways you could approach this. I mean, you're jumping up how many increments? You're jumping up 11, so plus 11. I'll tell you, you could just add on 11 increments of 55 and multiply them. If you want to crunch that number, you can, but I'll just focus on the graph because at this point, the arithmetic, I'm not too worried about. And we'll actually put a pin in this one and maybe even backtrack to figure out how I could have gotten there. So let's see. We can graph this out. The scaling of this, if you have a better way to scale it, let me know. And I don't like that line, so let's redo it. So let's have x be here, f of x be here. Notice I'm using f of x instead of y, but you could use y if you were feeling so inclined. So where do we want to start? We know that no matter what, we're paying $450 for just the parts. It's kind of an odd number to have to work with and start with, but maybe you could say that because it's not divisible by 55, maybe you could go with the fact that it's divisible by 9 so that you could say that, what is it, 945 divided by 9, where does that take you? If you were trying to scale this in a certain fashion. Because you can go up increments of 9. So you could pop up 1, 2, 3, 4, 5, but that's going to eventually have every little tick mark here go up 50. So pretty easy numbers to work with, I think. 150, 200, it's like 250, 300, 350, 400, 450, something like that's okay. And what would be the most interesting way to approach this? Let's keep going with the every 2 blocks is going to be 1 hour increment. I think that's fine. And let's go to the races. So we know that every hour we're adding on 55-ish dollars. It's just going to be slightly above this, which is fine. Slightly above the 500. If you're not convinced, that's slightly above 500. Check it. And then you can keep scaling this if you want, but honestly, after a little bit, you might just say, well, it's going to go in increments of 100 for every 2, and that might look cleaner. And you are more than welcome to keep running in that fashion. But again, we have 2 points. That's the minimum that we need. If you want to do more, go for it. If you're really proud of your graph, keep on graphing more. But in the interest of time, let's just say that it's going to keep going from 450. It's going to cruise through that 505 and it's out of here. Describe the pattern. You could say something similar to what we did before. I mean, I'll even let you take a moment to fill in the blank. You've been doing this since integrated one. Can you handle it? Starting at blank, we keep adding, and that's a giveaway, I guess. Blank, how many times? Take a moment, and the answer will be here in a second. You could have said starting at $450. We keep adding $55, X times or X hours. That's okay. You could also say it's linear, but that should be something you already know because it's a straight line and it's adding on in the same fashion. Let's pop over to creating an equation. So this will be the last little example we look at for this video. Like we'll definitely deal with the rest, but we'll see how these are done. And I'll do my best to give as much detail as possible. So recall, if it's an explicit equation, it's going to be in that form, y equals mx plus b. If you decide that you want to take the recursive approach, you have to have two things. You need to have f of your starting amount or starting hour in this case. So let's call it the start hour. So you need to know where you're starting. And then you also need to say where you're going, which is pretty much using notation like this all the time. It's f of x minus 1 and then doing whatever. We'll start with the explicit because we pretty much did it. I mean, if you look back here, we were saying starting at 450, we keep adding 55, x times. If we want this traditional y equals mx plus b form, you could say that it is 55x plus 450. These are both legit. These are both fine. If you are feeling so inclined, you can even say f of x equals 55x plus 450. And I guess that's more traditional to what this problem had going for it with the notation. So that's the explicit. This is the explicit. It's done here. You've been doing this since integrated one. If it rings a bell, great. If you're shaking some cobwebs, that's okay too. We'll keep practicing this. And honestly, the recursive is going to use the same idea, like the start hour. I mean, really, the crux of this is that we were starting at which hour? We joked about if we didn't even have the mechanics work on this, it would work for 0 hours, but we would have to pay 450. And then we would have to take our previous amount and just keep on adding 55. So this is the recursive. Pause the video if you're stuck. If something didn't quite make sense, please feel free to run through this again. Look at this. How much would it cost John if it takes the mechanic 16 hours to fix his car? Well, I think the easiest approach is to just use the explicit. Explicit's pretty sweet because you can just plug in any number of hours and get your outcome that way. So we said that we could have 450 and we could add on 55 and we're using 16 hours. So we multiply there. If you want to get awesome with notation, what do you think would go inside the parentheses for f of something now? Take a moment, think it over, and also crunch the arithmetic, and I'll have that here in a second. So a real spicy meet the ball is if you said f of 16 equals 450 plus 55 times 16 hours would eventually get you the $1,330 that it's going to cost if the mechanic does 16 hours of work and you got your parts from them. I mean, pretty nice. What do you think for this? This is now taking a little bit of a different approach. How many hours did it take the mechanic if it cost him $5,400 to fix his car? So remember back here in this table when I put a pin in it and said, hold on, we're going to come back to it. You can now hop back and write 1,330. That's cool. And now we're going to kind of work backwards because we know the increment of dollars, which is cool. We know it's going to be 5,400. But now we need to find the hours, which we said was X. And we know that our outcome, 5,400, could be written as f of x. So You could say that 5,400 equals 450 plus 55 times x. And that's legit. That's a good setup. I applaud you if you were thinking this. And then from here, if I taught you an integrated one, you might remember SADMEP. Pretty basic way to solve two-step equations. You're probably going to subtract something at first. So get rid of 450 from 5,400. This is now 3,950. And this now equals 55x. What do you think you can do here? I've already alluded to it. You wouldn't multiply, you would divide. And if you run the arithmetic on this, not 5x, that's silly. Terrible 5. 55, divide it, that cancels. And you're eventually going to say that x is approximately 71.8. What do you think? Dollars, cents, hours, cars? Hopefully you're thinking hours. Which kind of sounds, I mean, that sounds kind of odd to write 0.8 hours. I mean, you know that there's 60 minutes in an hour. If you have 6-minute increments, you could say that that's 10% and then do 8 times that. So really, this is like 71 hours. And how many minutes? What, 48 minutes? Is that your amount of time playing Grand Theft Auto 5 online? Which season are you on? Which pack do you have? I hope that this was a pretty good review of Linear. If you're stuck on anything, reach out. Thanks for watching.